Hi everyone, Marcos Colon here, Head of Digital Content Strategy at MISTI. I want to thank you for joining us for this very special presentation titled On the Bleeding Edge, 8 Predictions for the Internet in 2018, sponsored by Cloudflare. Now we have 2 very special presenters joining us today. First, I'd like to introduce Tim Fong, Product Marketing Manager for Security at Cloudflare. At his current post, Tim works with customers to help them adopt the very best and special solutions in security and enterprise networking. A graduate of Yale University and the Founders Institute, he previously held stints at Splunk, F5, AWS, and Palo Alto Networks. Now, leading today's discussion is John Graham-Cummings, Chief Technology Officer at Cloudflare, who's also a renowned computer programmer and author. John's worked around the world as a programmer, and in addition to authoring the travel book for scientists called The Geek Atlas, he's penned articles for The Times, The Guardian, and New Scientist, among other publications. So as you can see, based on their professional backgrounds, Tim and John are the perfect subject matter experts to lead today's discussion. Now, given that Cloudflare's global network is comprised of more than 120 data centers, there's no denying the amount of insight they have into emerging technologies. During today's presentation, John's prepared to run through his 2017 predictions and compare them to what actually happened. Additionally, he's ready to share his predictions tied to the internet and technology spaces for the year ahead. So sit back, relax, and get ready to learn things like what the most dominant cloud platform is, what the future holds for Bitcoin, what security concerns should be top of mind in 2018, and a lot more. Now, before we get started, a couple housekeeping notes. Keep in mind that the presentation will be available on demand after we wrap up. Also, the slides are available to download from that blue content button on the webcast interface. And also, to ask any questions at all, please don't hesitate to use that green Q&A button. Now I'm going to go ahead and hand it over to John to kick things off for us. John, thanks for being with us today.
Great. Thank you very much. It's interesting to talk about predictions because one of the problems with predictions is you get many of them wrong. And every year we do this, we take a look at what we predicted for a particular year and then how we did, and then look at the next year. So what I'm going to do in this presentation is take a bit of a look at some things that I predicted would happen in 2017 and how those predictions actually ended up working out. And then after that, I'll go through what my predictions are for 2018. So let's just recap some things that were in 2017. So one of my predictions was around DDoS attacks. And so in 2016, there have been some very large DDoS attacks happen, some of them as large as 1 terabit per second. And these affected companies like OVH in France or the DNS provider Dyn in the US, which affected many, many websites. And we thought at the time that very large attacks over 1 terabit per second were going to become commonplace. The actual prediction we made was that would be the baseline for a massive attack. And that sort of turned out to be true. But another thing happened, which was there was a fundamental change in the size of attacks and the frequency of attacks that we were seeing. In September of 2017, we introduced what's called unmetered mitigation, which means that we do not charge for DDoS mitigation at all, no matter what the size is. And we saw a dramatic change in the behavior of attackers. If you look at this graph, which shows the size in gigabits per second of attacks, towards the right third of the graph, we get to September where we announced that we were introducing unmetered mitigation, and suddenly there's a drop-off in the number of attacks or the size of attacks happening. There were still very big ones, some of them up to 0.5 terabit per second, but they were less frequent. And so what's happened is the strength of attacks is still there. The attackers can still do 0.5 terabit, 1 terabit per second as DDoS attacks, but they become slightly less frequent. And we think the reason for this is that Cloudflare and other companies have got extremely good at filtering out DDoS attacks. And so attackers have just decided not to bother. And in fact, have started switching strategies to using higher level DDoS attacks against applications themselves rather than at the network level. Now, another prediction I made on the next slide was around IPv6.
Sorry. There we go.
So IPv6 is a update to the basic IP protocol, which has been around for a long time, and it has been, in fact, the new version has been available for many, many years, but has not been widely deployed. Cloudflare was one of the companies that was pushing this, and the reason we need this is that there are a very large number of people and things getting connected to the internet. And it is getting increasingly difficult to have IP addresses for all those devices using the old version, which is IPv4. So IPv6 has been pushed out. And one area where this has become extremely common is in mobile telephone networks. Because of the number of devices and because the mobile operators actually control the entire network, they have been switching to IPv6. And we predicted that would become the de facto standard for mobile networks. This has pretty much happened. What we've seen is that companies like Verizon are now about 90% IPv6, and many other mobile networks are over 70%. So really IPv6 has become de facto in mobile networks, and you're probably using IPv6. On the other hand, what this graph shows is that if you look at the top 25,000 websites, it's really only, still under a quarter of them are actually using IPv6 natively. So what's happening is your mobile phone may be using IPv6, but somewhere in the network, there is a gateway device which is actually translating to the old version. And so although it's widely deployed in mobile, we're still living with legacy technology on websites themselves. And that over time is going to change as people want higher and higher performance and not to go through these gateway devices. Now, another thing I talked about was something in the security world to do with a thing called SHA-1. So SHA-1 is a hashing algorithm. It's a way of taking a file and coming up with a unique number that represents the contents of that file. And if that file changes in any way, the number will change. And it's a way of detecting change and is widely used for security purposes. One of the widely used versions of that is a thing called SHA-1, which has been used all over the web. And I predicted that what's called a collision would be found in 2017. And a collision is where two different documents they turn into the same number. And this should not happen. But it turned out because of a security flaw in SHA-1 that it was possible to actually generate documents that are different but have the same SHA number. And what I did here just to demonstrate is I have two versions of the Cloudflare logo, the old one and the new one, which are visibly quite different. And it's possible to put them in a PDF document and create PDFs that are entirely different, they look completely different, that have the same SHA-1. And this is actually the SHA-1 of those two PDFs, and these are available to download from the Cloudflare website if you're interested. A newer version of SHA, SHA-256, also sometimes called SHA-2, at the bottom shows that actually these files are different. They have different numbers using that hashing scheme. So that prediction came true. SHA-1 is, there are collisions. It is possible to make collisions very simply, and that means that SHA-1 is now largely dangerous to use for some cryptographic purposes. All right, moving on. One of the things I predicted was that the security of DNS would be taken very seriously in 2017. So one of the things that happened in 2016 with the DNS attack against Dyn was it was kind of a wake-up call that every piece of infrastructure is at risk from attackers. So it's very obvious when an attacker goes after a website itself and knocks a website offline. But if you can knock off the DNS server, which gets you to the website, then you've effectively done the same thing. And the 2016 Dyn attack knocked off a lot of websites. But we've also seen things like in Brazil, banking websites be attacked so that their DNS was changed so that you would be taken to a fake bank website. And there have been proposals for more secure versions of DNS. So I think this prediction came true. People started to look at the entirety of their infrastructure more carefully when thinking about cyber protection. And this particular graph here shows the deployment of a thing called DNSSEC, which is a special secure version of DNS over a number of years. So on the left, it starts in 2004, and you see slow growth in this over time. And now, in 2018, there's a significant number of websites actually have DNSSEC enabled. And this is something that Cloudflare actually provided. So I was fairly close to right on this one, although I think there's still more work to be done in terms of DNS deployments and securing them, because it's often overlooked that it's problematic. All right. So why don't we move on to 2018 predictions. So I'm going to run through some predictions for what I think is likely to happen in 2018 on the internet. So we're going to start out by looking at secure websites. Now, there's a very big change happening in security on the web, which is that Google, through its Chrome browser, is pushing very hard for websites to use HTTPS. That's the secure version of HTTP, which means that everything between your browser and a web server is encrypted. And the way that shows up today is it says secure with a green padlock icon in your web browser. What Google has decided to do is to do the opposite, which is to say that everything is secure unless it's not. And if it's not, it will, instead of not saying anything, it'll specifically say not secure. So what this is going to do is it's going to drive people to have HTTPS, sometimes called SSL, on their websites. And that's going to happen in June of this year. So that's pushing people in general to have secure websites, because end users are going to see sites that are not encrypted as insecure, mentioned very specifically by the browser. And Mozilla is looking at doing the same thing for Firefox, and we would expect Apple to follow with Safari afterwards. So that's a fundamental change to force people to use HTTPS. Now, my actual prediction was that by the end of this year, more than 50% of HTTPS will be using something called TLS 1.3. The underlying standard for the actual encryption that's happening is a thing called TLS. It used to be called SSL, and then it got improved. It's now called TLS. And there are a variety of versions, 1.0, 1.1, 1.2. The latest version currently deployed on the web widely is 1.2. And there is a new version, TLS 1.3, which has been rolled out, but it's been somewhat stalled by the need to get web browsers to support it as well. What we're predicting is that by the end of the year, that will have happened. The web browsers will be using TLS 1.3, and that will be fairly widely deployed. About half of all of the secure web will be using it. That will make the web even more secure, because TLS 1.3 is more secure than TLS 1.2, and it is faster. So we protect more secure and faster connections for about half of the web. All right, next. So an interesting thing is happening in cloud computing. There's been this meteoric rise of Amazon Web Services, Microsoft Azure, Google Cloud, which allows people to rent computer power and storage very cheaply and very flexibly. And many people have jumped to use these platforms to build out their applications. One of the things that was notable in Mary Meeker's 27 Internet Trends report was that when she started to talk to enterprises about their concerns around cloud computing, something big had happened. What used to be primarily a concern about security and cost, those two things have dropped down enormously. People are no longer so worried about the security of the platforms. They've been proved out to be secure. They understand the costs, and they can see what they're dealing with. They're now starting to worry about lock-in and compliance. And in particular, the worry is about being locked into a particular cloud provider. Because many companies have put their critical computing assets on, say, Amazon or Google or Azure, they're starting to worry that they will end up forever having to pay a sort of rent to those providers, and that they're not really in control of their destiny. That is now the number one concern for IT managers using the cloud. And what's happening is companies are now looking at multi-cloud strategies for how to deal with this. So they want to be able to, say, move workloads or move data between different cloud providers, say between Amazon and Azure, or between Google and Azure, or between Google and Amazon. In doing so, that means they will future-proof themselves, they will not be locked into a single platform, and they can get preferential pricing. We've actually had some of our own customers doing this already, using Cloudflare as the way to dynamically move traffic between different cloud computing providers. One such company is a company called Bill Forward, which provides billing services, and they actually move their traffic dynamically based on pricing between two different cloud computing providers who compete with each other. And they actually port the data between the two of them as well, so they're completely free to pick and choose between the two. And we think this will be a really big trend in 2018. The ability to use multiple clouds for a single workload so that people are not locked into a single vendor.
Hey, John, can I drill in just a little bit about that? So
yes,
you
absolutely.
said that you talked about Bill Forward, and you talked about how they escaped the cloud. Can you drill in one click down how exactly Bill Forward is doing this? Because I think a lot of people imagine you're locked in. Did they duplicate everything between the two workloads? And then when and how is the mechanism done for doing the switching? Could you just click down one how the decision is made when workloads are pushed from one to the other?
Yeah, so what they're doing is very interesting. They are they're duplicating the data between the two cloud providers, so they have similar data on both of them. And that's fairly easy for them to do. They're essentially replicating a database. And then what they're doing is they are dynamically using Cloudflare's load balancing product, choosing which cloud provider they can go to. So the load balancer could be used for actually distributing load, say, based on geography or the actual size of the load, but it can also be used for making a decision about, well, today we'll use this provider and not the other one. It can also be used for detecting when an origin server is down or not. So they're essentially treating it like they have multiple different servers on the back end and switching between the two of them dynamically. That can be done automatically through the API or through our UI. And that allows them to take advantage of the best computing power that's available, and also it allows them to do things like perhaps use one provider in one geography and a different one in another one if they have better performance or better service.
Great, cool, thank you.
All right, let's move on to the next prediction for 2018. So this is really around deep learning. So I think if you've not been hiding under a tree somewhere, you'll know that deep learning and AI has become absolutely massive in 2017 and going into 2018, with particularly things like home assistants like Alexa and Google devices, and now the HomePod from Apple being things that people can talk to and ask questions of. And there's a lot of hype around other ways in which this can be used for different types of problem that need to be solved in the real world. Probably the most visible of those is self-driving cars. These have been sort of on the horizon for quite a long time, and there are lots of experiments going on. We've seen a huge lawsuit between Google and Uber over technology for self-driving. We've seen Tesla have some small self-driving capabilities built in, and obviously Google famously testing out cars all over the place. My prediction for 2018 is that actually the hype is going to subside a bit. We've been up the hype cycle here, where everything was going to be AI powered, and in 2018 that'll actually really subside. And the thing that will make people realize the hype is overdone is that self-driving cars will continue to be experimental. We're not going to be able to go out and buy one. You're not going to be able to get into a self-driving taxi at any point. And so but the reality is that it will be a very good year if you are working in AI or machine learning, because although the hype will have peaked, the actual applications of AI and ML will still be there. And so we would think that jobs will be scarce, salaries will be extremely high, and people will be very well compensated for doing AI work. But the things that it's being used for will not actually be things that are perhaps quite as exciting as things like self-driving cars. But we might see things like traffic management on highways powered by AIs. Because it's the sort of thing where wherever there's currently a heuristic, we'll see AI applied. And so the hype will die down, but we'll start going into the beginnings of actually using AI for many different applications. It'll just become part of the background. But there will be a huge, huge demand for people with the skills to work on these systems. The other thing that's going to happen is that over the next couple of years, we're going to see dedicated AI hardware generators, so chips, equivalent to CPUs. Google has already started doing this. Apple has done some things in their handsets, and we'll see chips being manufactured for actually doing deep learning and machine learning.
Hey, John, so you said that there's going to be this trend, both hardware, software. There's some existing ML initiatives that are underway, and the salaries are very high. But how do people who maybe aren't already skilled enter that sort of work stream? Is that door closed, or are there ways for people who don't have it immediately? How transferable are other tech skills going into this, or is this just a whole separate work stream?
Well, I think there's a lot of these are things that people who are in tech can learn, and in fact, there are fantastic courses from people like Coursera, where people who are absolutely at the bleeding edge of AI actually teaching those courses. And so you can definitely skill up for this. There's definitely not something that's closed door at all. So it would be worth looking at, online courses at Stanford, things that are coming out of Silicon Valley, because there's definitely plenty of information. And a lot actually, although a lot of the AI ML stuff is very heavily mathematical, a lot of the applications, once it gets into using some of the models and systems, it's something that's quite accessible. And so I think it's really worth looking at some of these things, because a lot of this stuff is something you can learn, and also a lot of it's being done with open source software, so you can go download things, train them yourself today, and start experimenting. So it's definitely not a closed door.
All right, cool.
All right, so we go on to number 4.
Yeah.
So if you don't know this term, this is Kubernetes, sometimes abbreviated as K8S. And I'm predicting this becomes the dominant platform for cloud computing. And what I mean by that is that up until the real rise of things like Kubernetes and to a certain extent Docker for containers, the way in which people have run their computing workloads in the cloud has been to rent virtual machines and then configure those virtual machines with their programs and run them. And there are features available to scale up and scale down the number of them, but fundamentally you're renting a software version of a physical machine. There's a new thing happening, which is there are coordination platforms of which, orchestration frameworks of which Kubernetes I think is already becoming dominant and will really be dominant in 2018, which allows you to take a diverse pool of machines, be they physical or virtual, and run the workload you have, the programs you have on that, and scale it up and scale it down and configure it without really knowing in detail what the underlying hardware or software is. And what's going to happen, I think, is that if you go back to that thing about vendor lock-in, I think that people will start to insist that they can run their applications on Kubernetes because it will give them the flexibility, first of all, to run it, scale up, scale down, but also to move it from one cloud provider to another because they won't be locked into particular APIs or particular command line. They'll be using just Kubernetes, which will be common. And so I strongly believe this will become dominant across cloud vendors. And we're already starting to see the major cloud computing vendors offering Kubernetes compatibility, although all of them have their own slight incompatibilities, which of course creates some sort of lock-in. But I think the forces of Kubernetes and the fear about vendor lock-in will drive us to a point where it's very easy to move workloads between cloud providers because of Kubernetes.
Was there something about Kubernetes that made you believe that it would become the dominant platform? I know that there is other sort of open source projects, things that are kind of, was there something about the way they did it, or maybe not related to them at all, but just to the needs of customers and companies that made you think that Kubernetes would be the dominant platform?
Well, so Kubernetes is something that got extracted from Google. And Google, of course, has a great deal of experience running these large deployments of hardware and then running services flexibly on top of it. And so what happened was Kubernetes came out of Google, was open sourced, so everyone can see the source and contribute to it. And it had the kind of cachet of coming from Google, who's obviously dominant in this area, and also their push behind making it open source and supporting it. And I think, there are actually quite a lot of difficulties running Kubernetes itself. It's not an easy thing to set up if you do it from scratch. But I think there are forces which are, making that there's now a real center of gravity around it and a real momentum behind it because it had Google helping to push it. Now, you don't need to use Google's services to run Kubernetes. Right? You can run it on Amazon. You can run it on a Raspberry Pi. It's possible to do all those things. But Google is behind it and helping to, make sure that it's something that becomes dominant.
Yeah, cool. So it sounds like this is sort of the antidote to the lock-in that people were afraid of in your prediction number 2. So as this becomes more dominant, does the vendor lock-in start to disappear with this capability?
Well, I think what will happen is all of the vendors they'll support Kubernetes and they'll add their own value add on top, right? They'll try and keep you on their platform with something that's, Kubernetes Plus or Kubernetes Pro or some extra services that are on top. So I think it helps. But it helps. It doesn't fundamentally itself solve the problem of keeping data replicated between different clouds. And I think that's something that will get solved in 2018 as well.
Right, cool.
All right, let's go to number 5. So number 5 is about something which is really quite a technical and quite surprising thing, which is quantum-resistant cryptography. It's worth just talking a little bit about what that means. In 2017, Cloudflare actually did an experiment and open-sourced a quantum-resistant implementation of the new TLS 1.3 standard. So I mentioned TLS 1.3 as a brand new standard which has certain cryptographic properties, and we actually open-sourced an extension to it, which is a thing called SIDH, which is a cryptographic method which is resistant to quantum computers. Now, what does that mean? So almost all the cryptography that we use on the web relies on mathematics, which is easy to do in one direction. It's easy perhaps to encrypt, but it's difficult to go the other way. It's difficult to go back and do a decryption or break that. And strangely, most of that is based on a belief that on ordinary computers that we have today, what might be called classical computers, those algorithms are difficult to break. And there are mathematical reasons for thinking they're difficult, but there's no real proof. The actual underlying mathematics, it appears to be difficult. And they're difficult has an actual real mathematical definition of what they mean by difficult. That's on a classical computer like any computer you could buy today, no matter how big or small. There is another sort of computer which uses quantum effects called a quantum computer, which goes beyond the capabilities of classical computers. Now today, these machines are close to theoretical. There are some with a very, very small power. They can only handle a few bits at a time. But we've already thought through the algorithms that will run on quantum computers when we have them. And some of those algorithms allow us to break existing cryptography that is impossible to break on classical computers. So we know once quantum computers exist, the programs we want to run on them will actually be able to break all the cryptography we're using today on the web. So what do we do about that? Well, there's been research on this to build quantum-resistant cryptography. So what that means is quantum-resistant cryptography is something that cannot be broken on a classical computer like you own today or on a quantum computer. And so although we don't have the computers yet, because we know that it will be possible because the algorithms exist, people have worked on quantum-resistant cryptography. And my prediction for this year is that this is well enough established and there's enough fear that quantum computers may exist sometime in the not-too-distant future, that quantum-resistant crypto will actually get rolled out, particularly for machine-to-machine links, so between data centers, where there is a high risk that if somebody started to save that data, they might be able to decrypt it in a few years' time when a quantum computer comes along. Because one of the risks is that an adversary starts saving data on a vast number of hard drives somewhere and is able to go back and decrypt it in the future. And it may only be a few years before we have quantum computers capable of breaking the encryption we're using today. So I believe in 2018 we'll see actual deployments of quantum-resistant crypto in machine-to-machine links across the internet.
Cool.
All right, let's do number 6. So if you've been following Bitcoin, you've probably been following the price because the price has gone up and down in crazy amounts, sometimes on a daily basis, sometimes on a weekly basis, sometimes on every few minutes basis. And this vast instability in the exchange rate between dollars, particularly in dollars, and the Bitcoin price has led lots of people to jump in and try to build exchanges because there is money to be made. What that's led to is a large number of people building exchanges or other Bitcoin technology which is woefully insecure. The other day, there was a large heist of Bitcoin caused by the fact that the software that worked out whether you had enough money in your Bitcoin wallet only checked on the web browser and not on the server where the actual Bitcoin was stored. And that's a little bit like your bank. You go to your bank and saying, I'd like to take out £1,000, please. And the bank looking and saying, oh, you've only got 100, but giving you 1,000 anyway, because it trusted you to know that you had enough money, even if you didn't. And so this is an example of what I call security-based Darwinism. There are a vast number of these companies that are just going to collapse because they are woefully insecure. What will emerge is one or two stable exchanges, which I think will help stabilize the actual Bitcoin price as well during 2018. But the real message here is I would be extremely careful going forward about which companies you use if you are going to get into any sort of buying and selling of Bitcoin, because there are a vast number of very insecure companies out there.
Hey, we had a question come in about the association, similarity, difference between Bitcoin and blockchain. They're often associated with each other. I was wondering if you could have a comment to help clarify that.
Well, so the idea of the blockchain, which is this idea of a ledger of a recording of transactions, which every bank would use a ledger for your bank account, for example, which can be distributed. So it can be actually broken up into bits and very cleverly handled on machines that are not cooperating with each other directly across the internet. It's fundamental to Bitcoin. That's how transactions are recorded in Bitcoin, how you record how you paid someone. And using this blockchain technology, it's possible to actually have transactions going on without centralized coordination. And today, when you make a transaction with your bank, it's the bank is keeping the record of what actually happened and keeping track of your bank account. Within the blockchain, it's actually happening in a distributed fashion. So that is the blockchain technology which allows the transactions to happen in a distributed fashion. Bitcoin itself relies on the blockchain for the transactions, but itself has another part, sort of a little bit tied in with the blockchain, which is that there are a limited number of actual Bitcoins that can be created using a mathematical process. And over time, people are able to mine them and get a reward for doing so. And the reason that works is that these two things are tied together. So keeping track of the transactions people have done in the ledger requires you to do a bunch of complicated crypto. The reward for doing that crypto is you get some Bitcoin, so you make some money. The reason you get a reward is that you're actually maintaining the ledger. So it's sort of a mutual benefit that you get paid for keeping the entire Bitcoin system going. But blockchain can be used entirely separately from Bitcoin. It can be used for other places where a distributed ledger would be useful.
Great, thank you. So let's go to the next one.
Let's go next.
Go.
Okay, so mobile traffic. So this is this is a big thing that's going to happen, which is that more and more we are using mobile devices to access the internet or access applications. One important thing is that when you're using an app, such as, hey, suppose you're hailing an Uber in the street or you're flicking through Tinder, you're actually using the web underlying it. You're using an API that uses the web's protocols. So the internet traffic that you're using, whether it's in a browser or an app, is actually web traffic. But all of that's coming from mobile devices. And in 2017, we predicted that it would be 60% of all internet traffic. It didn't quite make it. I wasn't quite accurate, but we pretty much believe that this year that will actually happen, that more than 60% of internet traffic will actually be coming from mobile devices as people move away from desktop devices.
I'd like to drill in a little bit more. Like, what are the implications of this? And you mentioned it briefly when you talked about IPv6. What does it mean when more of the traffic that's on the internet is run through mobile? What needs to change, or what are the implications or impact to the applications or to users when that happens?
Well, I think the big thing is everyone will have probably had the experience that their home broadband connection, unless it has a genuine outage, is pretty fast and pretty stable. You can sit at home and you can be streaming Netflix and browsing the web and maybe doing a WhatsApp call over that connection. And it's fast and pretty stable. Everyone has also had the experience that when you're on a mobile device, depending on where you are, it can be very variable. So it could be fast, or it could not work at all, or you have the classic problem of, do I have a good connection? How many bars have I got? And we don't really have the how many bars have I got problem with broadband. And so as stuff moves more and more and more onto mobile devices, I think there's going to be more and more effort made around keeping those networks performant, so rolling out the latest standards for GSM, but also technologies that actually work around the slowness in mobile networks. So, for example, Cloudflare bought a company called NewMob, which does optimization of the connections between mobile devices and web servers, so that in spite of the kinds of problems you have in mobile networks with performance, you actually get a good experience. So I think the move to this will drive more and more people to use technologies like that to ensure that users have a good mobile experience. Because we've been pretty trained to expect almost instantaneous answers, right? I can just click on something and get an answer, and it's very frustrating, particularly on a mobile device, when that doesn't happen. The other thing is, as the web is going more and more secure, then we'll see mobile devices specifically telling you whether a connection is secure, and people demanding that they get the latest security on those devices because people are using devices for every aspect of their lives.
Yeah, that's great. Related to your TLS 1.3, does mobile make it harder for us to enforce this TLS 1.3, or are there additional security challenges, just as you mentioned with mobile versus just regular browsers?
It's quite similar in a way, in the sense that what are the problems that affect mobile devices versus the desktop devices? The problems are really around updated software. And to a certain extent on mobile devices, updated hardware to be able to support the latest standards. But anyone who's using a fairly recent device, one within the last 2 to 3 years, is going to be able to get on the latest security standards without much of a problem. And companies like Apple are taking security very seriously on the platform. The one thing I would say is, given how much of people's lives is in the device, good passwords, using the security features that are in those devices is very important, so that if you lose it, you can be sure that you have not, you've not lost your life to somebody else.
Yeah, that's a good point. Great.
All right, the last one is adoption of edge computing accelerates. I just want to talk about a little bit what I mean by edge computing. So if you think about the history of computing, in some ways, at some point you had very large, very expensive computers, and a small number of them, mainframes, in organizations, and limited access to them. There might have been terminals you could connect to them with, but there was essentially centralized computing. And then you had an explosion of desktop PCs. People could do stuff themselves on those PCs. So you had the PC and you were doing things. And then there was a move to the client-server era where all those desktop PCs got networked and you could access some shared resources like a shared database. But fundamentally, there were only a couple of places where you were doing computing. There was either on the PC, that's where there was a computer out, or on the server that was somewhere in the organization. And that didn't honestly change very much with the web. What do you have on the web? You have web servers which are somewhere, maybe they're in a cloud or maybe they're in a data center, and you have a device, a computing device like a PC, a Mac, or a mobile device talking to it. And there are two places where computation is happening, either in the server or in the device or PC. As we've come to demand faster and faster experiences, particularly using mobile devices, but in general, the speed of light has actually become a problem. It may seem silly to say that, but the speed of light, although it is very fast, when you're going back and forth between, say, your mobile device and a web server somewhere, or between your home machine and a computer which is in another country, because there's a back and forth to get information, say, to load a web page, then the speed of light can actually slow you down. So what you want to do is you need to push computation as physically close to the end user as you can, because then you eliminate that sort of last mile. You get it as close as possible. And that's really what edge computing is about. It's about taking some of the computation which is in large data centers and pushing it near to the user, and we refer to that as the edge. So when you think about Cloudflare's network, which has about 125 locations around the world, we rolled out a product called Cloudflare Workers, which allows our customers to do computation on our servers. And that means they can do a computation near the end user, not necessarily on their device, but near the end user, and get the results to them very, very quickly. And that gives you a better user experience. It also is the case that because the code they're running is in our network or on an edge network somewhere and not on the PC or device out there of every user, it can be updated very quickly. So something can be changed very rapidly to give them a new end user experience. So we think that this edge computing is going to be a big trend in 2018 as people take time-critical bits of their application and push them onto servers that are very close to the end user, so the end user gets the best possible experience.
Could you give some examples? So I got what you'd said, that because you have time-critical things that you want to run, you need to be as close to the end user as possible. What are some big examples that you think really illustrate the need and the value of edge computing?
Well, I mean, one interesting example is around, actually it sort of melds together the AI and things that are happening, is around security cameras. So it's possible to buy fairly cheap internet-connected security cameras for the home. And the reason those devices are actually fairly cheap is that they have very low computing resources in them. one thing you might want to do is have that device recognize, say, when your child comes home, by recognizing the child's face. But the device itself might not be powerful enough to do that. So what you can do is you can have the following happen. You have the security camera recognize that a face is in an image, because it's possible to do that fairly easily with a small processor, send the image to an edge device, which could do the face recognition and reply and say, okay, yes, that's your daughter who's just come home, or no, that's an unknown person at the door. And those applications are happening as a real thing. And the reason you want to do that as close to the end user is you can get the responses as quickly as possible. And you don't have to have such a large infrastructure doing the actual face recognition in a data center somewhere. So it becomes very cost effective when you're talking about millions of devices that are out there in the network.
Yeah, that's a good example. How would we know that it's actually accelerating in adoption versus we're still early? Or, on the other side, how do we know that it's been fully adopted? What's visibly going to change? That was an example where we're seeing compute-intensive things actually still being made with very cheap hardware. What other ways would we be able to know?
I think for the end user, it's going to be hard to tell, other than that the performance of the things they're using, websites and applications, is going to get better because we've moved the computation in. So they have rich experiences which just always seem to work, because in fact that has been pushed into the network, if you like, and off of these servers which are very, very far away. So I think you'll see that some applications and some websites will just work better than others, particularly in the mobile world, when you've got a combination of edge computing and these latest protocols.
Okay. Cool. That's great. I'm going to check if there's any new questions. We had questions kind of coming in through, and I kind of threw them out. But I'm not seeing any additional questions somebody wanted to ask in the last moment. I can go back and sort of see if there's anything that they missed. There's one question which we passed that came through, and I think this might be the last one then, was what are the good uses of quantum? So you talked about quantum computing. It seemed theoretical, but it's going to happen. But somebody may abuse it by storing data. Now, what are the plans for quantum computing that are, I guess, for good as opposed to for evil?
So it's interesting you say that, because the sorts of problems that we call hard, which include the cryptographic problems that we want them to be hard because we don't want cryptography to be breakable, that become easy with quantum computing. There's a large class of these problems, and some of them are crypto things, which is disappointing that we can make them easy with quantum computers. But there are others which will become much easier with quantum computers. So there are lots of things that computers have to do that you would seem very simple, but actually, as the data sizes get larger, become very hard to do. So, for example, one of the classic examples of this is the traveling salesman problem of somebody visiting every town in a certain region, and they want to work out the shortest possible route to do that, to do a tour of every location. That is computable, but it is very slow to do as you increase the number of locations you want to visit. And it turns out there's a whole world of problems like that will get easier once we get onto quantum computers. And so what we should expect to see is that some things that were infeasible to do with the classical computers become easy to do with quantum computers. And so we'll end up being able to do richer things. I think this will particularly happen within AI, where they're dealing with the sorts of questions we need to do for AI systems will just become a lot easier once we have a quantum machine.
Great. Cool. All right, one last scan on the Q&A, and looks like we tackled all the questions. So I think we're all good on this end.
All right. Well, that about wraps it up for us, folks. I want to say many, many thanks to John and Tim for being with us today, sharing all of that great and interesting information, and additionally providing us with even more insight by answering those questions that came in throughout the presentation. And also, I want to thank everybody that tuned in today to John and Tim's awesome information and presentation. So thank you guys very much.
Great. Thank you very much.
Bye-bye.